Hello everyone, my name is Alfahan based at Free from 4 Bank S2 with ID B0218100015, and this is my video presentation for my final year project for the Virtual Innotech 2022, which is application of simultaneous thermoelectric cooling and heating to improve the performance of a solar steel under Dr. Azdiana binti Mayusof. Without further ado, let me tell about my project which covers the energy harvesting of green technology. This project is about improving the already well-made solar steel that has been used since the pre-Incan or around the 14th century. I know that some people still doesn't know what is solar steel, so without any delay, let me tell about it.
So, what is solar steel? Solar steel is a green energy product that uses the natural power from the sun to purify water, where the process uses sunlight and heat from the sun to purify water from impurities in plants to get clean water. Nowadays, solar steel are still in use by the military that are stranded somewhere or place that have limited access to clean water. And there are many methods that can be used to make a solar steel, from a simple fit method to a complex method of pyramid solar steel. What is needed to do with the current solar steel? Solar steel nowadays usually have low rate of water collection due to its dependency on the heat from the sun and the surrounding rate of humidity, where there will be low sunlight rays coming from the sky. Thus, the environment temperature also drop, making the evaporation of water decrease over time. So, to overcome this, the solar steel will be designed by using thermoelectric application of heating and cooling. As I mentioned before, thermoelectric cooling and heating will be used in the solar steel. But the question is, what is thermoelectric? To make it simple, thermoelectric is an effect of direct conversion of temperature difference to electric voltage or vice versa between two different metal plates. And there are three main effects of the thermoelectric. But for this project, we will talking about the Peltier effect, where when a Peltier is charged by electricity, the different metal that sandwich together will create different temperature on each side, which one side is cold and one side is hot. What is the objective of the project? The first is to design a solar steel using the thermoelectric application of heating and cooling. Second, to analyze the heat temperature for water evaporation and the level of water collected over time. And the third one is to develop a real-time monitoring system for the solar steel. How to make the solar steel? First, by designing the solar steel by using SolidWorks and run a simulation of the design to know whether the design can be used or not. The designing of the solar steel will consist of three parts, which is the base of the solar steel, the basing, and the cover of the solar steel. Next is by making the real-time monitoring system for the solar steel by using MEMOS D1R2 as the main microcontroller, DS18B20 sensor for sensing temperature of the water and the surrounding in the solar steel, and water level sensor Arduino for sensing the level of water collected in the bottom of the solar steel using freezing. For the thermoelectric, the peltier will be put below of the basin of the solar steel. As for the coding, we're using Arduino IDE with the library of ESP8266 installed inside of it to run the coding and to read it. And the coding consists of two, which is the water level sensor and the temperature sensor. And then there are the TeamSpeak coding for connecting to TeamSpeak analytic platform. This is the fully assembled project demo where there's a 12-volt battery to run the monitoring system and the thermoelectric filter inside the solar steel, and it's connecting to a buck converter to control the incoming ampere to the circuit and the peltier, and connecting to a junction box to store the monitoring system. And there are two buttons, which are the button for turning on the monitoring system and the thermoelectric system And next is the solar steel, which consists of the basin inside of it, and there's a temperature sensor inside the basin, a water level sensor at the below of the base, and below of the basin are the thermoelectric system. For the result, the project using ThinkSpeed analytic platform to monitor the current condition of the solar steel, where the temperature keep rising over time and the level of water stay flat due to its slow process of water evaporation. So there's a need of improvement to make the evaporation rising.
For the conclusion, the project managed to achieve the target, which is to improve the performance of a solar steel by using the thermoelectric, and we managed to make a real-time monitoring for the system. For any inquiry about my project, you can contact me through my email or through my LinkedIn page. Thank you.